Now let's talk a little bit about the ice shelves themselves. We said that the biggest one is the Ross ice shelf. You can see it here shown by the red cross. But there's also the Larsen ice shelf, which has an interesting story. In 1995, a large area of the Larsen ice shelf simply disintegrated and broke into thousands of pieces. An area of 2,000 square kilometers broke into thousands of small icebergs as a result of a single storm. It's questionable whether this is climate change or just because of the storm, but we're seeing this happening more and more often, that these ice shelves are being broken up and disintegrating. Since the 1940s, we've observed a warming of about 2.5 degrees occurring in the peninsula of Antarctica near the Larsen ice sheet. This peninsula points towards South America, to give you a reference of where we're looking. And this is resulting again in, it doesn't change the sea level because these are already floating in the oceans, but there's other problems related to the ice shelves because they act as the brakes of the ice sheet, which is on the land. They kind of are braking and stopping the flow of the ice from the land into the ocean. Other ice shelves which have been breaking up, we can see, as I mentioned, there's the Ross ice shelf, there's the Muller ice shelf, which has been receding since the 1970s, the Wardy ice shelf, which has broke up in the 1980s. And so it could be that this is related to climate change. Again, the water underneath the ice shelf is warming, and so this also has an effect of the melting from below, but we also have changes in the type of storms, the intensity of storms, which can affect also the breaking up of the ice shelves close to the ocean. It's fairly clear that temperatures are warming there, so it could be related to global warming. Here we can see the trends from 1981 to 2007. I should point out again, we have less warming, regional warming in Antarctica than we're seeing in the North Pole, in the Antarctic. Still a debate of why we're seeing less warming in Antarctica, since it's also in the polar regions and we have the snow ice albedo feedbacks. One of the ideas is it's maybe because of the ozone hole, which is formed mainly over Antarctica, and because of the symmetry of how Antarctica is really right over the South Pole and the flow of the air over Antarctica is very symmetrical, this keeps Antarctica very cold and doesn't allow for the mixing of warmer air from higher or equatorial latitudes, which is the different in the North Pole. But we won't go into the details of that, and that's a whole new area to talk about the ozone hole. But the ozone hole could be linked to somehow of the rate of warming that we're seeing in Antarctica. So the ice shelves, as I mentioned before, act as brakes to the flow of the ice sheets from the high mountainous areas, the high altitudes, towards sea level to the oceans. We can see that in number one here, the panel number one, where we have the glacier flow, the ice sheet flow towards sea level, the lowest place due to gravity, and then this flows out over the ocean, producing the ice shelf. But climate change and warming of the air can result in two effects. First of all, we can have melting of over the land. We can get these melt ponds, these moulins, which cause these waterfalls and crevices, which can result in instabilities in the ice sheet over the land. But the warmer waters as well can result in additional calving over the ocean and break up at the end of the ice sheet, which can result again in this negative mass balance. And if we go to panel number 3, if we get rid of the whole ice shelf, it breaks up completely, then again we're removing the brakes for the glacier, and we can have an acceleration of the flow, as we can see in number 4, of the ice sheet into the ocean. And if we take the land ice, and even if it accelerates and floats, and we put this into the ocean, then obviously this has an impact on the sea level rise. You can think of taking a block of ice and putting it in your drink. All of a sudden you have a rise in the level of your drink. So when we have the ice shelf melting, it doesn't impact the sea level, but this ice shelf can actually, if it disintegrates, can result in the acceleration of the ice sheet, which will eventually impact sea level rise. So here we can see first of all, on the top, image of one of these ice shelves, which are floating on the ocean. And then in the bottom image, we can see this animation of a satellite image, which can show the breakup of one of these ice shelves. And you can see this iceberg, which has formed, which is huge in size, which is now detached from the ice shelf. We can also see additional ones, which will eventually float and move with the ocean currents to warmer waters, where they'll eventually melt and mix in with the ocean water. And here's a movie of the Larsen ice shelf, which broke up again in 1995 over just a number of months. So this ice shelf, and again in 2002, you can see this is a 2002 from February, March, April. Within a few months, the whole ice shelf basically disintegrated. You can see here the mountain and the mountains which surround the ice shelf, which are this ice sheet. But here you can see the fragments of the ice shelf. This you can see before that breaks up. You can see the little, well, if you see the movie again, there are little black dots on top of the ice shelf. Those are the pools of water which are starting to melt and causing the instability in the ice shelf. And eventually, when you get a certain threshold and maybe a storm comes by and there are waves, this whole thing can break up just in a few days, few weeks.